All right. So let us just start something hands-on with MATLAB. This is the home page of MATLAB. We have first window that is known as command window. We have another window that is workspace, and third window that is current folder. And we are going to discuss all the basics about these windows. Let us just start with command window. Command window is the basic window where I'm going to put my commands and getting answers of it. And after making some syntax mistakes, I will get my errors on command window as well. So let us just start. A is equals to 1. Let us say I have put this first command on my command window, that is A is equals to 1. And see, it has given me the answer A equal to 1 on command window itself. So it is ready for the next command. Let us say I am writing A is equals to, or by mistake I pressed enter. So it has given me an error that means invalid expression, or something is missing, or some extra character it is saying. It is just suggesting you that it could be an error, but it will always find the syntax error. It will not give you any hint about your logical error. Like other technical languages, here also we will get syntax errors. So on the same window, command window, I got my error. So let me finish my statement. I was writing b is equals to 2. So again, I get the answer on my screen. And if you notice, as I am putting a equal to 1, b equal to 2, it is getting updated on workspace. So how actually workspace works? It is the RAM of MATLAB. RAM means random access memory. Whatever answer it is getting, whatever data it is getting, it will get saved in workspace. But if you don't save your workspace, this data will get vanish after your work. So we will discuss how to save the workspace. See, this is the space saving icon on my home palette. We have saved workspace. Just press this button and you'll get the current folder. We are right now in C drive in bin folder. How I get to know it? Because MATLAB is pointing towards where the MATLAB setup is right now. It is right now in C drive bin folder. This is MATLAB setup. So no, I'm not going to save anything in C drive bin folder, because it will create some confusions after large storage of your files and data in the same drive where the setup is present. So please don't save anything in your C drive and bin folder, which is by default folder in current folder here. So please find something better. How can I save my data into MATLAB? Suppose I want to save my workspace. So what you can do, you can make your own folder by using mkdir brackets. I'm giving the folder name. Let's say mat underscore online. Okay, so press enter. No, I cannot get the access while I am in C drive. So what I can do, I can change my drive, open any of your favorite drive wherever you want to place your workspace data. Again, mat online. Okay, it has made me a folder here, Mat Online here. Please see, just double click on it and you are in D drive Mat Online folder and it is empty right now. Make sure whatever data you're going to save, make a different folder in some other drive. It should not be C drive, okay, which is by default path of MATLAB setup. So, okay, I have created my Mat Online folder here to save my workspace data. I have two values in workspace. One is A and one is B. So let me just press this button. Right now I am in Mat Online folder and by default it is getting the file name MATLAB. Let us just change the name M1. It could be anything. M1 I am taking. Please notice it is creating .mat file. .mat file means whenever you save the workspace data, it will create a .mat file for you. Okay, save. Please check on current folder. We have m1.mat file, which is actually the workspace data. All right, so I said that workspace is a RAM of MATLAB and it will save your variables until your MATLAB is working. Like if you just stop MATLAB, these data will get vanish. So I'll use one command to clear my workspace, which is clear all and enter. And my workspace is clear now. But if I want my data back, I have this M1 file, just double click on it and it will load your m1.mat and your data is here again. So nothing will get vanish, but the condition is you need to store your variable data. So what are the values? What are the variable names? You need to store them first. Okay, so till now we have discussed command window. Command window will take your commands, give you answers and give you the errors. This is the most important window. Second window is the workspace. It will carry your values of all the variables in it, and it is a RAM, random access memory. It will get cleaned up whenever you close your MATLAB. So before losing your data, you just save your data. How to save? Just press save workspace, get a better path. Don't save anything in C drive and you'll create a data file .mat file by using mkdir. It's a function. Give any name to it in strings. There's single quotes. These single quotes are mentioning that they are string. These two strings I'm using, mat and online. And it will create a folder for you and you can save your data. All right, so these three basic windows, I hope you're clear with them. So I am using one more time clear all, but not as a command. I have a clear command button here. Clear command and clear workspace also. I want to clean my command window. Clear command, all the mess is cleaned up, and clear workspace means clear my workspace. Okay, whenever you want to return your workspace area data, you can just double click on it and get your data. All right, okay, so these are the three basic windows. Instead of pressing this button, we have a command also, CLC. This is the basic command. Okay, one more window I have. If I want my backup of works, this command window, how will I get this command window backup? Because I have cleaned up all the data from here. Okay, so where I'm going to get this data if my some important code is written there, but it is cleaned up. So you just go to the layout button, press this layout button. It will give you the layout of your MATLAB arrangement of these windows, like default is this, which I am also using this default layout, 3-column layout, current folder, command window, and workspace will come up as a corner side. And if you want only command window, minimize all of them are here. See, workspace is here, current folder is here. Right now they are docked. If you want to undock them, change your layout. Okay, let's default. All right, so I was talking about one more window, which is known as command history. Command history is like you can view it with two ways. One is pop-up, one is docked. Right now, pop-up is on. How can I see my history? Just press this arrow, up arrow key, and see all my commands which I have used to explain you. I have just used these commands. But before that also, I have all the history. What command I have written on that day, that time. So I'm getting all these. Just press the up arrow button. You can remove it. And if you want your command history to be docked, just press dock here, and it is here. Double click on it. You have a command history also, but date and time, everything you're going to get on your screen. And if you want to repeat any of them, just press double click on it. Just double click. Let us just double click any of the command. Any simple command. Let's say pi by 6 plus pi by 4. Double click on it, and it will just run on your command window and give you the answer. So it's very easy to actually get your lost data, which is not lost actually. It is saving in command history, which is dogged mostly. So how can you minimize it? You can just minimize it or undock it. So it's right now in pop-up table. Okay, so these are the basic 4 windows. I hope all these four windows are clear to you. So let us just start today's topic, which is matrices and arrays. It is very important to work with matrices because the name of the subject is Matrix Laboratory. So we are going to learn how the matrices, how the data is forming, how we can apply the operations on it, and how we can like manipulate the array data which we have. We want to work on it. So let us just start with a comment. Put a percentage sign, and it is a documentation. Whenever you put a percentage sign, the compiler of MATLAB will not read it. Okay, so my first topic is matrices. Matrices. Press enter, it is not going to read it. This is for your documentation, for users documentation only. All right, so how can I enter my matrix? A is equals to square bracket. Please use square brackets, and let's say you have some data. You can use space or you can use comma. Both are same, and I'm using semicolon in between. I'll just show you. I'm using space here. See, I have just used space here 2 times and semi-comma here. Again, the commas, comma and space here. Let us see what is my result. Okay, this is my result. 1, 2, 3, 4, 5, 6, 7, 8, 9. It is showing that in matrices, space will separate your column, and it is again separating the column here. Semi-comma will separate your rows. So here, semi-comma is separating your rows. Again, comma, and here also see, row is getting separated here. So this is how you can enter your matrix into MATLAB, and you can apply different, even I would say many functions on it. How you can make this matrix, how you can get the transpose of it. Let us just do transpose. B equals to A dash. This is transpose, means in B we have transpose of 1. See, all the rows have become columns and column becomes rows. Okay, so let us just do some more things on it. Just for example, I am using magic of 6. Now, what is magic? Magic is a predefined function. Magic is a predefined function. What is predefined function? We have many predefined functions in MATLAB. Their algorithms, their mathematics is already been written in documentation of MATLAB, and MATLAB is offering you those algorithms by using their names only. Okay, so these are predefined. MATLAB know what to do. Okay, it has created you a 6 cross 6 matrix. As you can see here also in workspace, A is being updating regularly. Okay, here 6 cross 6 double. We will discuss what is double, but right now just concentrate on 6 cross 6, and it has created a matrix. Now the question is, from where all these values have been like in A, where I'm getting from this. Like magic is a predefined function, and it has an algorithm in MATLAB documentation where it is designed to create n cross n matrix. N means whatever integer you are giving here. N cross n matrix, and the magic behind this is, see, I'm using one more function here, sum of A, and I am putting it in C, sum of A. See, the sum of all the columns, 35, 3, 31, 8, 30, and 4, and so on. Sum of all the columns is same here. Okay, so this is the magic. First, it is creating n cross n matrix, and the sum of all the columns is same. This algorithm is already been written in MATLAB. I'm just using it. Okay. So let us just manipulate this. Let us just reshape my matrix. I have this matrix in A, so I want to reshape it. How many elements do I have in this? Yeah, 36 elements. Okay, so we have 36 elements inside this matrix created by magic, 6 cross 6, 36. So I'm going to reshape it, or you can say I'm just doing resizing. Okay, resizing of my matrix. So I am using D is equals to reshape. Again, a predefined function, okay, which is already defined in MATLAB. Reshape A. I'm going to reshape A, but what will be the new shape? 36 is the answer when we multiply 6 into 6. 36, where I'm going to get 9 cross 4, 4 cross 9, or 12 cross 3, or 3 cross 12. So these could be your new shapes. Let us use 12 cross 3. Okay. Yes. So my data is same, but it has been reshaped. Okay, reshape is my predefined function. Firstly, it requires what is the matrix and what is the new size, new shape you want. I have just mentioned 3 input arguments. 3 input arguments means I've just mentioned 3 input arguments here. Okay, and the magic is designed for only 1 input argument. It is designed only for 1 input argument. So the question is where you are going to get the explanation that which of my function, predefined function, is doing what and how it is designed. So you can use help for it. Help magic. Help magic. Enter. Yes, you'll get the documentation behind MATLAB. And okay, they got magic, not these, they don't want these brackets. They are giving you magic. Magic square, n cross n matrix constructed from the integers through n raised to the power of 2 with equal rows and columns and diagonal sum. We haven't noticed that all the diagonal sum is also equal. 35, 32, 2, 17, 14, and 11. This will also be 111. You can check it out on your own, but you can get your explanation by using help and your predefined function. Okay, again, I'm using a is equals to magic of 3, suppose, a smaller one. Okay, one thing you just notice, I have used a many a times, like I am changing the value of a again and again. Please note it down that all these values are getting overwritten. Okay, they are overwriting the previous values. So please be aware whenever you are giving the output argument, please be sure that you are not going to lose your previous calculation or previous data. Okay, right now we have lost magic 6 and right now the answer is magic 3. Okay, so whenever you are doing something important, please use output arguments in a better way or in a defined way. Don't use one variable again and again because it will get overrated. All right, so magic 3. Let us just put sum of 15. All the values of like addition after addition, we are going to get 15. Okay, one thing I haven't mentioned any output argument space for sum. So what it will do, it will get by default output argument, which is ANS, answer. Okay. All right, so let us just move forward. I can create random matrix also. Random 3 cross 3 or 4 cross 5 matrix. See, again, answer has been updated here. So please give output arguments properly. All right, so my rand function is going to give me a rectangular matrix. You can give the size here 4 cross 5. Okay, but can you notice something? Here I am going to get all the values below 1. Means the values are in between 0 and 1. All the values are in between 0 and 1. Okay, please note this down, that rand will give you this kind of random values, but it can give you the rectangular matrix. Okay, you can calculate sine of ANS. ANS means answer. Right now we have this random matrix in this, and let's just save in Z, enter. All these are sine values of elements, every element. Okay, it will get applied on every element. But please note, sine will give you values in radians, not in degrees. Please write this down. It is not going to give you the value in degree. To get the degree values, how will you put? Sine D. Sine D of ANS. So whenever you are doing some calculation, please mention D if you want the degree sine values. Likewise cos D, likewise tan D also. Okay. Okay, so these were the trigonometric functions which are predefined for MATLAB. Sine, cos, and tan will give you radian values. Sine D, cos D, and tan D will give you the degree values. I hope I'm clear. Okay, let us just go to the next type of operation, that is logical operations, or I would call it logical operators. So we have logical operators in MATLAB, and they are and, or, and not. Okay, let me just enter something here, magic of 3, and I'm putting semi-comma because I don't want to see my result. I know what is going to be the answer. So I'll put a echo suppressor here. Echo suppressor means it will suppress the output, save the output in workspace. Update it, but it will not show me on my command window. See, let me just use I of 3, and again the semi-comma here. Where is the answer? B is equals to 100, semi-comma 0, 1, 0, semi-comma 0, 0, 1. This means it is creating a unity diagonal matrix. Okay, if you want to see what is the answer, just write B here, and this is the answer. Unity diagonal matrix. So I is a predefined function which will give you the unity diagonal matrix. Okay, so next thing, we were using logical operators here. Logical operators means and, or, and not. So let me use A and B. Enter. It will again give me a logical array as an answer. And what is the answer? Let us just see here. 8, 1 means both have some input. Answer is 1. AND gate. 1, 0 means one input and another is 0 input. So output is 0. This is satisfying AND gate. Here, element wise, it will check and give you answer as in logical array. Logical array means 1 means yes, 0 means 0 means no. Okay. All right. So next is OR gate. I'm using this OR sign and enter. OR means okay, everything is 1 here. Why? Because we have at least one input in A. Okay. OR solution means it should have one input at least. Okay, so we have this logical array 111, and if I want to use not, this is the sign for not in MATLAB, not of B, and B is my I matrix. Okay, press enter. It will reverse everything because not gate will complement your answer. 0 becomes 1 and 1 becomes 0. Again, a logical array I get. I hope you get it. The logical arrays. And next is let us do some indexing. Indexing on matrix. Okay, there are two types of matrices. One will be row matrix, or we usually call it as a row vector. Second is my column matrix, or it is known as column vector. So let me just give you example of a row vector. How can I use row vector? This is my row vector 7 and 8, and you can extend it. Enter. So what is the size of this array? I can use my predefined function size of A, and you can save it. Let's say I'm saving it in M. So the size is 1 cross 8, means 1 row and 8 columns. Okay, and another thing is, let me just use, instead of comma, I'm using semi-comma. Okay, now see the size of your matrix. Size of A, and put in N, and 8 cross 1 means 8 rows and 1 column. Okay, so these were my matrices, row vector, or we usually call it as a row vector and a column vector. Okay, so when we have whenever we have a two-dimensional matrix, we usually call it array. We call it array. So I have already shown you how we can enter the array. Here I'm only using magic to get my matrix because it saves my time. All right, so this is my matrix of magic 6 cross 6. Here, let me, okay, let us just assume that I have entered this, okay, and this is my very important data. By mistake, I have written 32, but the value was 13. The value was 1, 3. Okay, by mistake, I have entered something wrong here. So what I can do? Should I write my data again? Should I enter my data again? No, I will go to that position and change the particular value. So how we can go to the particular value of any matrix in MATLAB? Enter A, because A is my matrix. Small brackets. Which row? It's a second row. Okay, and it is a second column. Second row and second column. 2 comma 2. 32. And if you want to change the value, just put equal to a square bracket, and it was 13, not 32. In matrix, in your parent matrix, you could say the value will get changed here. All right, understood? All right. So next is, if I want to change my submatrix. Submatrix means I want to change my 33, 17, and 10. These three values. I want to change these three values. How can I do? I can just write A for 33, fourth row and third column. Fourth row and third column, and let's say it should be 10. Okay, 10, but for 17, again I need to write the command. For 10, again I need to write the command. So it is very like time consuming. Instead of this, we can use a operator here, that is colon operator. This colon operator in MATLAB. Before explaining that, we were doing previously that we were changing these three values one by one by using colon operator. I'm going to do this with one step only. So for that, I am explaining what is colon operator. Let me just use 1 colon 10. This shows 1 to 10. 1 to 10 means from 1, you're going to write every value 1, 2, 3. Like you're going to write a series, okay, by using colon operator. That means 1 to 10, lower limit, colon, upper limit. And by default, it will take interval of 1. Step size also we call interval or a step size of 1. Okay, so if you want to change the step size, 1 colon 0.5 colon 10. 0.5 is my step size. Step size means equally like separated values in the series. So here 1, 1.5, 2, 2.5 and so on till 10. So lower limit is decided, upper limit is also here, and the interval is also here. So this is how you can write your series with a particular interval. So this is a use of colon operator here. So I'm going to use my colon operator concept here to change the values in one step. These three values I wanted to change. Let us just see. It is fourth row. All the elements are in fourth row and columns are third, fourth and fifth. So how I'm going to write here is a fourth row, third to fifth column. Always write row first. Always mention the number of rows first, then comma, then the number of columns. Okay, and just take them out. Yes, this was the value 10, 17, 10. 10 we just changed in the last step. Okay, so I'm going to change here by using equal to and new values. Let's say new values are 100, 100 and 100. They could be different also. I've just taken for example. So, okay. So 100, 100, 100 in one step. So this is known as positioning, or this value like row, comma, column. You're mentioning rows and columns. So this is known as subscript value. Subscript value of your matrix. Subscript value includes your row number or the column number, and whatever you want to do, you want to take that portion out or you want to change that value, or you can delete that those values also. So it's up to you whatever you want to do, but this positioning by the use of rows and columns is known as subscript value. Okay. The second type of positioning is index value. Index value. So if I want to change a particular value here, let's say I want to change 9 here. What is the index value? 1, 2, 3, 4, 5, 6, 7, 8, and 9. Oh, it's 9 and 9 value also, 9 position also. Let me change the position, the value. Let's say I want to check the value of this, check the position of this value. 1, 2, 3, 4, 5, 6, and 7. The position is A7. E7, enter. Yes, it's 1. And if you want to change it, you just put equal to and uh, let uh, let me change it to 100. Okay, so by using this kind of pattern that you are using A7, it could be A36. Okay, so you can write A36 here, 3636, and again the value 100. So I have changed this 36 value. So likewise 35, 34, 33, every position you can just count and reach there what the index value of that matrix is. Okay, this is how you can get the position value and change it. You can delete it, whatever you want to do. We have just discussed how to get the positions of matrix by using subscript value, row vector and column vector values, and the index value is that position where this your value is situated. Okay, so I think we were using colon operator here. Let us just do one little exercise. I have a matrix which is magic. I'm using my previous commands, magic. Let us just do some operation on this submatrix. 7, 21, 23, 22, 2, 22, 27, 33, 17, and 10. This 3 cross 3 submatrix. I want to take this matrix out and I want to change the values and I want to update my A matrix all in one step. Just see how I'm doing this. So second row, third row, and fourth row. Row means second to fourth, okay? And the column, third, fourth, and fifth column, okay? So you can use third to fifth column. Second to fourth row, third to fifth column. Yes, this was my submatrix. And if you want to change the value, just put equal to, and here I'm using ones of 3. 3 means if I have chosen this 3 cross 3 matrix, I need to replace them with the same size. Okay, so here I'm using 1, 1, 1. Ones is a predefined function which will create the ones matrix of n number. N could be anything. Here I have used 3. Okay, so this is how you can use the subscript value and index value. Okay, one thing, suppose I have questioned you, my value is at A26. Please change that value. This is wrong value. A26 is the index position of my matrix values. A26, change the value to 1000. Whatever is written over there, just change the value A26 with 1000. What you will do, this is my, let us just assume this is my data A, and A26 means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on. You're going to count every index position. This is very tough. So for that, I am going to use my sub to int function. Sub to int function, it will help you to find A26. Where is A26? Because right now it is 6 cross 6 matrix. What will happen if you have 600 cross 600 matrix? You're going to sit and count 1, 2, 3, 4. No, this is very tough job, an impossible job sort of. So what we are going to do here, this is my A matrix and I want to see A26 by using what is, where is A26 here? So X sub to int means subscript value to index value. Here I'm going to use size of A, and that subscript value is very easy to find. How? Please go to this icon, yellow color icon, double click on it, and you'll get one variable window here. That 6 cross 6 matrix here, same matrix you'll get here. And let's just think A26 could be this. Okay, so I'm using 5th row and 4th column. 5th row and 4th column is it, the subscript value is easy to find. Okay, so let us see 5th row and 4th column. Is the answer? No, it's 23. Okay, 24, 25 and 26. Second row and 5th column. I'm checking it. Second row and 5th column, 26. So this 26 means A26. Means index position A26. Here 1 is written, already 1 is written. So how you can change A26 is equals to, let's say, 1000. Easy to find the subscript value by a variable window and very easy to change the value. A26 is equals to 1000. So 1000 is updated here. So you can use this thing vice versa also. You can put your index value and get the subscript values out also, or you can put your subscript value, you will get the answer of your index value also. Okay. So this was your positioning of matrix values and how you can change them. So one thing, you can create your row vector by using colon operator. It is very simple. I have already told you, but there is one more predefined function, that is linspace. That is linspace 1, 10 till 5. What is this? Let's just get the answer. 1 is your lower limit and 10 is your upper limit. See, 1 is your lower limit, 10 is your upper limit here, and 5 means 5 equidistant points. Equidistant means every point has equal distance. If you minus this 3.25 with 1, will get the equal value, and again if you minus the upper and the lower value, will get the same value. Equidistant points you will get with the linspace function. Okay, so let us see some more operations on Magic 6. Magic 6 I'm taking because this is easy to just get the example as to work on. Okay, so it is very easy way to get my data, random data. All right. Oh, so what kind of operations we can do? We can do arithmetic operations also. arithmetic operations on matrices. So if you want to add something, some value with your matrix, you want to multiply, you want to do the raise to the power, you want to get the exponential, you want to get the inverse of your matrix, eigenvalues of your matrix. So we have lots of operators and predefined functions which can perform mathematical operations or arithmetic operations or the calculus operations on your matrix. So let us just start with some addition. Okay, A is equals to magic of 3. This is my A, and let's use B. It could be my own matrix 1, 2, 3, or another. This is my own matrix. So I'm going to add these two matrices. How? Very simple. A plus B, and I'm going to get answer in C. Simple. Likewise, we can do minus also. We can get the minus values wherever the B is greater than A, it will get minus value. And how we can multiply the things? By using asterisk sign. Okay, so let me just say 8, and this is my B1. 8 into 1 is equals to 55. How is this possible? Here it is matrix multiplication. This is the result of matrix multiplication, not the dot product. This is not the dot product. This is a cross product. Okay, so how you can do the dot product in MATLAB? You just put a dot asterisk here, dot asterisk, and so you'll get element wise multiplication. 8 multiplied by 1 is equals to 8. 1 multiplied by 3 is equals to 3. 6 multiplied by 4 is equals to 24. So if you want dot multiplication, you can use dot in between. Okay, likewise you can use the raise to the power also. Likewise you can use the raise to the power also. This is raised to the power of B. A raised to the power of B means all the values are getting multiplied, means getting the power of B. A power of B, and it is element wise getting multiplied. Okay, so this is the sign for raised to the power. You can get the exponential of your matrix. Let's say I use this exponential. If you want to use the inverse of your matrix, this is inverse of your matrix. You want to get the eigenvalues of your matrix, this is eigenvalue. Very simple. These are the arithmetic operations, and these are very simple operations that we have used in matrix. Thank you so much. We'll do lab after it. Okay, so we are going to do lab. Lab means some exciting questions, and we are going to solve them with the basic concepts of matrices that we have already done in this class. Okay, thank you. Bye-bye.